Hi, everybody. Okay, I'm gonna stop talking about science and talk a bit more about how to, how some people is trying to use this information for decision making. Okay, so where do we see people using this information and what for? We see basically two different overarching goals. One is reporting the financial implications of climate change for investors and to meet sustainability requirements. And the other one is to build in climate resilience for climate proofing assets. So the first one is more about meeting requirements, and the second one is because we see more and more people being actually worried about the impacts of climate change and trying to make something about that. So in terms of meeting reporting requirements, there are more and more recommendations and regulations about climate disclosure. So people has to report in their sustainability assessments, or they have to report because there are regulations requiring people to report about what are the financial implications of climate change in their assets and operations. And there are a few of these frameworks. The task force on climate-related financial disclosures started, I think, is one of the older ones. It started a few years ago, about 7 years ago, and the idea was that climate change was going to be the next driver of a very serious financial crisis, similar or worse than the one in 2008, and because of that, the financial ministers of the G20 decided or got together in this task force on climate-related financial disclosures, and they started with recommendations about how companies should report on climate-related risks. And these recommendations are becoming mandatory in more and more jurisdictions. And in Europe in particular, there is the EU taxonomy, which is a series of regulations or more of a taxonomy. So it's a sort of classification of what is defined as a sustainable commercial activity, and there are different criteria that the commercial activity has to fulfill to be defined as sustainable. And two of these criteria are related to climate change, specifically in terms of fulfilling the climate mitigation targets. So how the commercial activity is impacting on the climate, and also how the climate is impacting on or might impact in the activity in terms of what are the risks that the climate change might pose on that activity. So how do we see this is affecting wind farm projects? As I said, in terms of the task force on climate-related financial disclosures, some companies are doing this analysis more at the portfolio level. There are also companies interested in doing screenings at the particular asset level. For instance, because they had to fulfill sustainability requirements of the lenders. One example of that is the companies having to developers having to fulfill the requirements of the Equator Principles, which are again principles related to sustainability and how investments are defined as sustainable. And in Europe is the EU taxonomy, which companies are doing at both portfolio and asset level. Okay, as I said, the task force on climate-related financial disclosures, and many of these sustainability requirements look at climate risk in two different, or they divide climate risk into different groups. One are the physical risks. So this is the actual impacts on the assets and operations due to extreme events like flooding, droughts, and chronic events, which are like more monotonically increasing events like sea level rise and average increases on temperature, for instance. And the other set of risks are related to what are called the transition risk, which are more related to changes in policies, for instance, implementation of carbon taxes and how that can affect the operation of, an obvious example is oil and gas companies. So that will be changes in policy, changes in technology. So the shift from, for instance, combustion engine cars to electric cars. And also something that is talked about more and more often is liability. So companies might end up being liable for damages caused by the physical impacts of climate change. So in the next few slides, I'm going to focus specifically about physical risks. And so this is an example, or this is the example of the classification of climate-related hazards for energy assets according to the EU taxonomy. And you see there a very long list of physical risks divided into chronic and acute. Chronic are the monotonic changes, for instance, changes in P50. And the acute changes, which are related to extreme events like heat waves, wildfires, cold waves, etc. And the risks are divided into different kind of different types, like temperature related, wind related, water related, and solid mass related. And the EU taxonomy requires that climate risk and climate risk and vulnerability assessment has to be performed to assess the materialities, how these extreme events will impact on the different aspects of operations. And in the case of wind farm, could be revenue through changes in resource, or revenue changes due to changes in that are needed, for instance, on operation or management and maintenance because of the impacts of these extreme events, and also impacts on infrastructure and capital expenditure. So, so if I go back here, we have the chronic changes and the acute changes. How can we look at each of them individually? For acute hazards, or this is just an example of what a series of acute hazards we can take into account. So, for instance, heat stress, which could be heat stress in terms of how this can affect humans, so heat stress for humans, but it could also be heat stress in terms of the impacts of heat waves or extreme temperatures on, I don't know, the functioning of the wind farms or other type of assets. Other examples are fire. So we can find information in the climate models to estimate what are the climate metrics that can be related to each of these hazards. For instance, heat stress in humans will be a combination of temperature, humidity, wind, and radiation to calculate a metric that will tell us what is the felt temperature by humans. And then what we had to be able to estimate is how these hazards will change in intensity. So climate change might impact an extreme event in different ways. They could become more intense, they could become more frequent, they could become longer. So a drought might start being longer than what it was typically was. So that information has to be combined in order to estimate what are the risks associated to these acute hazards. And then there are the chronic hazards, and these are just examples that could be relevant for a wind farm. So changes in mean air density, changes in P50 or P90, what are the changes in magnitude that are important, and then associate the level of risk to those changes. So for instance, for changes in mean wind speed, there was a lot of talk today about not the changes in mean wind speed not being driven by multi-decadal variability or being within the range of the interannual variability, which is true, is what we get from the climate models, but change in multi-decadal variability can be, I don't know, 1-2%, and that might be still impactful for the project. So that's the kind of thing we had to think about when trying to estimate what are the risks associated to these hazards. And the numbers in this slide are examples that has to be evaluated depending on based on what we know about the particular assets. So this is my list, putting everything together, the chronic impacts, the hazard, the chronic hazards, the acute hazards, and these are just examples: changes in mean air density, ice changes in the percentage of icing days, mean precipitation, mean wind speed, extreme cold that can affect the wind farm, extreme heat that can affect the wind farm. So the things that we have to think about is what are the impacts, what aspects of the operations or of the infrastructure, of the revenue each of these hazards might affect. We can identify what are the risk levels associated to each of these hazards, and it might happen that perhaps in an initial analysis, the changes in mean wind speed, for instance, we know that if the changes are large, that will be significant, and the level of risk will achieve like a high level. But there might be other things where changes might not be that as important. So it will, even if they are big, they will never achieve a risk level higher than low, for instance. Obviously, these are just examples based on our what we see, our experience, but all of these has to fill in based on the knowledge of the particular asset. We know from the climate science point of view what to look at, what metrics to look at, what information to get from the climate models, but the actual translation into risk requires much more information than just that. And the final thing is how to incorporate model uncertainty. So there was some talk today about the uncertainty in climate model projections, and this is not something that we will get by the equivalent of taking information from ERA 5, calculating the number of heat waves or the changes in the intensity of the heat waves, and we will get just a number. We will get 20, 30 climate models giving different information. So there will be uncertainty in the estimation of this risk. So it might happen, for instance, that we find that changes in mean wind speed. We have, just to give you an example, 13 climate models, and some of them project, so I don't know, 80% of the models project a medium risk of the changes in mean wind speed being significant. And then we had to somehow communicate that or assign that information or put that information somewhere. So the one way to do that is to think about model agreement. So if all the models project the same kind of changes, we could say there is a high agreement on the changes, and then we can say with higher confidence that's the risk will be high or medium or low. And that's the information that we think we should include in all these analyses, and is what appears here in the last column. So coming back to the table in the European taxonomy, this is probably what we want at the end. We want the table, we want to color in each of the boxes and say what is high risk, what is medium risk, what is at low risk, and then be able to propose what are the adaptation measures that have to be taken in order to lower the risk if that is the case. So for instance, in this case, and this is again just a random example, no impacts are expected, nothing has to be done. But if there are risks that the risks have been found that might have an economic impact into the project, the expectation is that there should be some adaptation measures proposed to obviously to lower the risk. So this is just something that we saw in a presentation 2 weeks ago in the Copernicus Climate Services. There was a person from the European Investment Bank, and he was talking about what they are doing in terms of evaluating the impacts of climate change in their investments. And he emphasized that this is the sort of steps that have to be followed, or well, that they follow. And so there is initially the high level screening by region, country, sector, and then so this will be like at very high level, at portfolio level, which countries are more at risk. Always thinking about particular assets. So for instance, wind farms everywhere. What are the places that are high risk? What are the places that lower risk? And then then zoom in and go look at location specific screening. And then you will need more information, more data, more analysis. And in places where they find that there is more risk, the level of risk is, well, that has to be defined by, say, medium or high, or medium and high. Then there is another layer of analysis that has to be done in order to really understand what are the causes and how to mitigate those risks. And this is taken from the final slide is what we see with some of the people we work with is that even if you go to this stage, okay, now what do we do? How to actually plan for adaptation? What are the adaptation pathways, and how to implement those measures? And in particular, how do we make sure that there are that the information is robust, and that the pathways that are implemented do not lock us in the wrong pathways. So how to implement measures in a way that we are not, basically, there are no regrets in 5 year time, because the information changed. We had more data, more climate models, different information. So I think that one of the things that are missing, well, there are many things missing, but one of the things that are missing is actually how to implement these decision-making processes that at the end will end up with adaptation, the adaptation pathways that people have to implement.